Thank you for the invitation to speak during this seminar series. I was here about a year and a half ago talking about slightly different topics, still related to salmon, of course, but I might touch on that a little bit later on in my presentation. I had intended to be there in person today, so I apologize. I had a float plane reservation, and there were some wind warnings for later today in Victoria, and I just thought, it's just maybe not a good day to take a float plane. So I decided to just stay put in Nanaimo. So I apologize for not being there in person. I was looking forward to it because I haven't been over to UBC in a few years, I think. So my presentation is on South Coast area stock assessment. And you can see in my title that I have salmon in parentheses. And that's because it's not actually part of the name, but at South Coast area stock assessment, we only do salmon stock assessment. And sometimes there's a little confusion between the stock assessment that takes place over and the science sector, and rightly so. My presentation isn't going to be a typical scientific presentation where I present a paper. It may even sound more like a promo for stock assessment. And that's because since I arrived at stock assessment earlier this year, I've really been very impressed by the scope of the program. And also, as I've gotten to know folks, I have been very impressed with their passion and their dedication and their work ethic. So, and I also want to acknowledge the stock assessment team for, I'll get this video going again, for some of the drone footage here, and also many of the wonderful photos that I have in my slideshow. This is, I'll warn you, this is the first time I've given this presentation. And so I actually learned even more about stock assessment as I was putting the presentation together, because we do so much. And so I hope I will do my best to represent the stock assessment team. I will just take one slide though, just to note that there's a lot of, I can see there's a lot of folks on the call who I know, and so they definitely associate me with salmon tracking work. But I have taken on a new role earlier this year at DFO as the area chief for salmon stock assessment. And this is definitely a different role for me. So I've gone from conducting research to really managing what I consider to be a large team. And but I just thought that I would just reflect for a moment on some of the work that I've done before I arrived at stock assessment. So I spent a number of years working on kind of salmon ecology and early marine survival and migration. So if you've been in the salmon world, you've probably seen some of these animations that Cantama produces. And so this particular one is showing Chinook salmon from the Columbia River migrating up the continental shelf and being detected by acoustic receivers deployed in the ocean. And you may be more familiar with some of the sockeye animations from Chilco, because we worked with Scott Hinch and his lab for a number of years, and Cantama is still working with Scott Hinch in the lab. So I wanted to show this particular video because it really does show the full scope of some of the work that we were able to accomplish using acoustic telemetry, which really is a remarkable tool for assessing salmon in the ocean. Okay, so where is the South Coast area? The Pacific, DFO has a Pacific region, and within that region, there's the 4 areas. And the South Coast area includes Vancouver Island and the mainland inlets here, just north of Howe Sound, up to Cape Caution. So Pacific Fishery Management Areas 11 through 27. This map shows 28 and 29. That's not in our area. That's the Fraser area. But we do inform some of the management of Fraser salmon because the Fraser stocks do migrate east and west of Vancouver Island, and we do collect data, catch data for Fraser sockeye. I'll talk a little bit more about that. Okay, so South Coast area stock assessment. Who are we? So I've got some pretty good pictures of some folks at stock assessment. This one's just, I thought was spectacular. So in general, We are a team that includes nearly 40 full-time biologists, technicians, and several admin staff. And of course, as you know, most field biologists, a very hard-working team in all kinds of different conditions. But they love their jobs. That's what they tell me. So that's fantastic to know. And they get to go to, or we get to go to extraordinary places. This is the Southgate River. And so sometimes these extraordinary places are only accessible via helicopter. And so that's pretty unique opportunity as well. And then, of course, they get to witness extraordinary fish. And they made it work through the pandemic. And I wasn't at stock assessment during the pandemic, but from what I have seen, some of the programs had to be canceled, but there was still quite a bit of work that was able to get completed. That's mostly probably because of the nature of some of the work being outside. But I just do want to acknowledge them for being able to get the work done through the pandemic. So what do we do? So my presentation is mostly about what we do because it's so extensive, and I'm still learning. Before I go on to the next set of slides, I just want to point out the bear tracks in the sand here. And so as I was putting the slideshow together, I came across many bear photos, black bears and brown bears. And so perhaps I should have put that the stock assessment group is also very brave, although it seems to be quite common that they encounter bears if you do field work. So there's quite an extensive list of what we do. So I'll just start at the top here and break it down. So we design monitoring programs and research programs using a number of different methods and techniques. So we build elaborate traps, both for juveniles and adults. We build fences, many fences and many different systems where we are able to, and the fences funnel this is for adult escapement counts. And so the adults are funneled in through a tunnel. And so we have many, I'll talk more about that, but we build many fences. And this is so that we can look at run times and abundance. So in this particular plot here, this is from recent data from the Cowichan River. And the red line is what's called the fence count. So the number of fish that are migrating upstream of the fence that we've deployed. And you can also see the abundance and the run timing here and how that compares to previous years. We also use Ditson in the rivers in order to enumerate adult fish returning to the river. We use pit tags in our work. Now, this doesn't show a pit tag, but it shows you the pit tag operation on the Cowichan River next to the rotary screw trap. And the pit tags are used for estimating survival downstream, as well as survival of those same fish as they migrate upstream when they return, and also allows us to calculate a smolt to adult survival rate in some cases. We're beginning to use acoustic tags, and I suppose we'll probably be doing more of that in the future. We've also been incorporating drones into the program. So our technicians are getting licensed to fly drones. And so that's pretty exciting work and gives us a new perspective. And there's also quite a bit of an incredible amount of sampling that takes place. And so the samples that we collect, the tissue samples, usually it's a fin clip, they go to the genetic stock identification, they go to the molecular genetics lab for genetic stock identification. And so that's another technique that we use. So the first and the second bullet, there's obviously a bit of overlap there, but I'll talk a little bit more about how we monitor salmon in juvenile salmon and adult salmon in the ocean and in the marine environment. So in freshwater, we typically monitor juvenile salmon as they migrate downstream by deploying these rotary screw traps. And on the right, you can see a collection of fish from the trap. And this allows us to identify and enumerate and sample juvenile fish during their downstream migration. We also sample juvenile fish in the ocean using beach seines, and we also use seines off of small-scale seines off of vessels during the summer residence time. We've also been micro-trolling in the fall and the winter time, which I don't have a slide of here, but it's another way for collecting juvenile fish in the ocean. There's just a nice shot of some juvenile salmon. Okay, when it comes to monitoring adults, we begin the monitoring as the fish are approaching their spawning rivers in the ocean. We work with a number of test fishing vessels, and the test fish, in this particular case, they're using a seine. And this is a photo taken during the Barkley Sound sockeye test fishery. And so the test fisheries, they provide abundance estimates, run timing, and also catch composition. So the test boats sample a proportion of the catch, and the samples, as I mentioned, they will take tissue samples and send it to the molecular genetics lab for a kind of like a rapid genetic stock identification. Within a couple of days, they'll turn around from submission of the samples. The lab will process the samples and provide us with the population identification in this particular case, and that helps to inform the way that in-season fishery management program is run. So the data come back from the lab with the various populations at the same time, and that's provided to one of our stock assessment biologists. At the same time, the biologist is getting fishing information, if there's an open fishery, fishing information from the recreational sector, from commercial fishermen, and also from First Nations. And at the same time, we're enumerating fish in the river, which I'll get to here in the next couple of slides. But using all of that information, we're able to update the forecasts that were made prior to the opening of the season. And then there's a weekly meeting that takes place. And in that meeting, the numbers are reviewed and the allocation is discussed and either upgraded or downgraded. So the Barkley sockeye test fishery, the whole in-season fishery is quite an impressive operation. So once the adults move into the rivers, we conduct a number of intensive escapement surveys. And there's approximately 20 rivers where intensive, meaning that there's about 6 to 8 that happen over the upstream residence or migration. And there's a number of other systems that are surveyed, maybe just several times, but there's about 20 that are intensively surveyed. And these escapement surveys are done via snorkel. So you can see the person here in a dry suit, kind of, I think, at the end of their snorkel survey where they're meeting some rapids. And so this is not your typical snorkel trip. This water's super cold. In this series of photos here, there was snow up on the trees. The water's freezing. So I really acknowledge the stock assessment folks that do this and the partners that also do this as well. But it allows us to, these escapement surveys, and I guess I should explain escapement. Escapement is a term that's used to just describe the adult salmon that have escaped the fishery. So they've gone past the fishery and they've migrated upstream. It's essentially a way to say the spawners. It's the fish that return to spawn. So the snorkel surveys allow us to get a visual count of the adult salmon that have returned to the river. And then we use that data to calculate an area under the curve estimate for escapement to the river. And I want to show this incredible drone footage. This is from our partners, MC Wright and the Ditidat First Nation. This is a drone video that was taken, this is the Nitnat River, and you can see clearly the schools of salmon. And this might be a little bit clunky because I had to reduce the size of the video, but you can see those, you can clearly see the schools of salmon. You can see, if you look carefully, you can see that there's anglers on the beach. You can see fish jumping. And you can also see, just at the top of your screen, you can see that there's a couple of snorkelers coming down. Those aren't recreational snorkelers. Those are two people that are conducting an escapement survey. And I think one of them was from stock assessment and the other might have been from the hatchery or from the Ditidat First Nation. So the drone footage gives you this spectacular aerial imagery of these schools of fish. And then the stock assessment staff, or the surveyors, the snorkelers, they will be able to get kind of more of the density of that school. So they'll be able to see the depth of how deep that school is and approximately how many fish are there. So we've been using drone footage to bolster our escapement estimates. Okay. Okay. We also, when the fish are in the river, we also have a number of fishways or fish ladders that are that are equipped with video cameras. And so you can see on the left-hand side, it's a little bit hard to see, but there's a fish ladder at the top of it. There's a box. The fish swim through the box. There's 2 active videos, sometimes more, and that allows us to identify to species, individual fish. And the fishway allows the fish, in this particular case, to get around those rapids you can see in the background. I have another video of a video. So this is a nice clear view of the fish migrating through the box. They sometimes go through in small groups, but oftentimes it's enough to get a count. And you can also determine whether that fish has an adipose fin or not, which would indicate whether it's a hatchery fish. Okay, so we also monitor salmon fisheries. And so we have a very extensive creel survey program, and we conduct about 10 to 15,000 surveys annually. And a creel survey, if you look at the left-hand photo, is simply just a questionnaire that is filled out by the creel surveyor while they conduct an interview with the fishermen. So the information that's asked of the fishermen is essentially where they were fishing and how many fish they caught of all species. So the creel surveys do go beyond salmon, but we also, when fish are brought back to the docks and the ramps, we also sample the catch. And the samples, I should mention, if I don't think I have it on any slide anywhere, that we will submit up to about 30,000 tissue samples to the molecular genetics lab this year for fish stock identification. So we also conduct over 200 overflight surveys annually. So overflight surveys are conducted in a float plane, and I had the pleasure of being able to get out on one of these surveys earlier or just a couple of months ago on a beautiful day, thankfully. And the pilot and the observer work together to essentially to count all of the active fishing boats below. And so in this photo here, you can see there's a bit of a cluster of fishing boats on a fishing hotspot. And if you can't see them all, I've gone ahead and circled them here. So this allows us to estimate the recreational catch, the recreational fishing effort. And the float planes, essentially they fly up the straits, down the straits, up into, they kind of poke into all the various inlets, counting active fishing vessels. We also have the IREC program, which is the Internet Recreational Effort and Catch Reporting Program, which has just had its 10-year anniversary. So that was developed by a stock assessment about 2 years ago, and it's now managed with stock assessment and the science sector at DFO. And this is like a mandatory self-reporting program. So when you buy a fishing license, a recreational fishing license, it is mandatory for you to participate in this reporting program, but you are selected randomly to participate in for 1 month out of the year. Okay, so we also monitor river conditions. And this is something that we are starting to develop a bit more, but some of the monitoring that we do in the rivers started with the installation of some of these hydromet stations or hydrometric stations. So initially, well, these stations that you can see on the right-hand side, these stations collect data on river temperature, air temperature, rainfall, and barometric pressure. And initially they were installed in remote locations so that staff would have and there's a live satellite link, so we could access the data to see what the conditions would be on site. Because as I mentioned, sometimes these sites are only accessible by helicopter. We don't want to charter a helicopter only to get to a site where the conditions are too dangerous to do an assessment. So we do have this bit of a time series that we're developing now from 25 different rivers in the area. And we're beginning to think more about how we can use these data as an indicator of salmon productivity. So as you can imagine, all of the kind of monitoring that I've shown you here has resulted in quite a bit of data. So managing the data is a major job. And then we also take the data and we summarize it, analyze it, and it's used for various purposes, which I'll get into here. But I also want to just mention that we also respond to quite a few data requests. It's not uncommon. And we provide with the data that we collect, we provide scientific advice to our collaborators in the department and outside of the department, and also harvesters, NGOs, and First Nations. And just as an example, and because I think this is a really great figure on the left-hand side, this figure on the left is the fecundity of Chinook salmon relative to body length. So we know that the larger the fish, the more fecund that fish would be. But what we've seen over time is that there's a decrease in the size of the females when they return. And so that means that if we have smaller females entering to spawn, we have fewer eggs in the system. So we've started to take a management approach of managing for the number of eggs in the system as opposed to the number of female spawners, because the female spawners have gotten smaller. On the right-hand side is a cohort analysis for the indicator stock on the west coast of Vancouver Island, showing the age-specific exploitation rates. And so it's this kind of information and analyses that are being used for the development of a rebuilding plan for West Coast Vancouver Island Chinook. So that's just one example of how the data can be used and incorporated. But also, one of the products, a major part of what we do is we produce a number of bulletin series. So I think that we produce at least 15 different series and bulletin series. And so we produce a number earlier in the year on juvenile enumeration. And so when I say a series, there'll be a number of bulletins that are produced for a particular system and then updated weekly. And so we've got juvenile bulletins, we've got adult escapement bulletins. We produce in-season fishery management bulletins. So I was mentioning before the Barkley Sound sockeye. There'll be a forecast, and that forecast of the return will be updated weekly with the new information that's coming in from the test fishery, the other fisheries, and the escapement, the fish going through the fishways, and the cameras. Then these bulletins will show this information on a week-to-week basis. And then there's an in-season weekly meeting. I think I mentioned that earlier. So these bulletins are critical for providing information to all of our different First Nations and stakeholders. We also produce a recreational catch monitoring bulletin. And so if you're interested in, these bulletins are not published per se. They, in order to receive the bulletin, you have to get on an email list. So here's the address that has the email addresses for individuals that produce some of the bulletins. I know it's a very long address there, so you can always contact me if you're interested in the bulletins or subscribing to them. There's not like a standard subscribe to this particular bulletin. You just have to request it via email. So last but certainly not least here is the years that Stock Assessment has spent developing relationships with First Nations and partner organizations. So the field work that's conducted is not done solely by the Stock Assessment Group. 40 people couldn't possibly cover all of Vancouver Island and the mainland inlets. So we work with a number of First Nations, and we also work with a number of other organizations and NGOs and universities to carry out our stock assessment programs. And it just wouldn't be possible if we didn't have a lot of participation from groups that we work with here. And as another example, I want to show you, this is a recent bulletin that we released. It's an escapement bulletin for the Strait of Georgia. And at the back of that bulletin, you'll find a list of all of the individual groups that participated in basically counting salmon in the stream. So this is snorkel surveys or stream walks or different ways of collecting data on adult escapement. So this is just the Strait of Georgia area, and you can see here we have a very extensive list of groups that we coordinate with. So it's very impressive. Okay, so why is it important for salmon management? So I've mentioned the in-season fishery management piece, but I also think that I also want to mention that the data that we produce also goes into developing the fishery management plans. We have several staff that participate in Pacific Salmon Commission committees, such as the Chinook Technical Committee. We contribute quite a bit, as you would expect, to the Pacific Salmon Outlook, and we also provide data for developing recovery potential assessments and rebuilding plans, and so much more that I didn't want to. So the less glamorous part of the job that I haven't really discussed is all the meetings that we attend in order to get the data in the field to these publications or these policies that are cross-sector and across our whole region. So there's quite a bit of meetings that take place as well. And I just want to wrap up talking about some of the future challenges. And so on the right-hand side, there's the most recent world scientist warning of a climate emergency. And so I've just highlighted from, some of you may have seen this publication. I've just taken a few figures from their dozens that they presented. They've updated some of the time series. And so just a few that I just wanted to point out here was that we've got CO2 continuing to, in our atmosphere, continuing to rise. methane. The temperature here seems to be somewhat stable. So I guess there's some questions whether that's a COVID effect, but let's hope there's some stability that's actually occurring. That's the surface temperature, by the way. But we also have the ocean absorbing more heat while becoming more acidic. This global warming and resulting habitat loss will result in declining productivity and increasing variability. And we've already seen that. There's many examples of that happening. And if we continue on this path, it will result in declining fisheries, more restrictions, which we've seen, and more competition for the resource, which is happening. You know, it's really easy to manage when we have a lot of fish. It's going to be much more challenging. It already is challenging and will become much more challenging when we have fewer fish. And I don't want to dwell on this too much, but I just wanted to show the surface temperature projections from the IPCC, and just to mention that we have been warned that if we go past 1.5 degrees C, there could be irreversible damage to our ecosystems and our planet. And so what does this mean for salmon? So some of the folks here may have been to the International Year of the Salmon Symposium, where Brendan Connors presented this slide here, Brendan Connors and colleagues. So what this, I thought that this was a very impactful slide when I saw this. So what this figure is showing here, what the slide is showing here, is the using a business as usual climate model scenario. So I think that's kind of considered the worst case scenario, that the habitat for sockeye salmon will shrink by about half. And so if I understand this correctly, that means that the any of the sockeye populations entering the ocean east of the Aleutians will be entering an, I guess, somewhat uninhabitable ocean. And so we're already seeing declines in Chinook salmon, and I mentioned at the beginning of my talk that I would come back to what I talked about a year and a half ago. So this is from a paper that was published by David Welch and Aswia Porter and myself 2 years ago on the coastwide decline of Chinook salmon on the east coast of North America. So we are already seeing these widespread declines in Chinook salmon. This is mostly for indicator stocks. And some of the things that we don't hear about, though, are the lesser studied species, such as chum, which are also have similar declines to Chinook salmon, in some cases worse. So how do we manage salmon in the future? Well, I'm not a salmon manager, but I have been working very closely with salmon managers, and I provide data to make science-based decisions. And there is a little bit of hope here, that if you look at the plot of the CO2 emissions, we have some hope here. I need to wrap up, but this could be just a pandemic effect. But I think that regardless, we need to adapt and plan for future declines now. We need to identify refuges, and we need to be honest about potentially losing some salmon populations, particularly in the southern part of the range. But there are some actions that we are currently taking, and one of those is to try and create some more stability in the fishery by rolling out some mark selective fisheries. And those would be, when you say mark selective, just means that it's a hatchery fish that was marked by having its adipose fin removed. And so you can identify it as a hatchery fish. And then in a terminal harvest, only hatchery fish are harvested, and the wild population will be released to spawn. And we can continue to improve our knowledge of salmon productivity by understanding some of the limiting factors. And we can also improve our catch reporting. So despite the effort that goes into catch reporting, we still can refine those efforts a bit. And so I do think that we have our work cut out for us. I do hope that we can continue to, as I said, managing salmon when we have a lot of salmon is much easier than we do not have that many salmon. There's just not enough to go around. And so I do hope that with some of the work that we do and some of you may have heard of the Pacific Salmon Strategy Initiative, which is an initiative by the Canadian government to improve salmon populations. So I'm hoping we're going to see some success from that particular program. And I think I should wrap it up there and take any questions for the last couple minutes. Thank you very much.
And yeah, thank you, Erin, so much for your presentation and the super valuable information regarding the program that you're now heading. Carl, you had a question regarding salmon in small streams. Please go ahead.
Hey, Erin.
Hi, Carl.
DFO has stopped reporting in the last 2 decades any escapement information at all for a lot of the small streams, particularly around the Georgia Strait and so on. And hints from personal experience are that we're seeing widespread extinctions in those small streams like around Baines Sound and on the east coast of Vancouver Island. Do you have any plans to try to use the expanded funds you have now or will have now to try to get some idea of what's going on in a lot of those small systems?
Sorry, Carl, I didn't hear you at the very end of your question.
Do you have any plans to try to restore some kind of basic monitoring on this large number of small streams that we no longer see being reported in the NewSEDS database at all?
Okay.
And I know you're not visiting a lot of those anymore at all.
Right.
It's amounts to close to half of all of the streams in the South Coast. There's no NewSEDS data at all in recent years.
Yeah, so as you know, Carl, I don't know the history of all of the streams that we monitor. It's an extensive list, and as I showed in my slide, we have a number of collaborators that work with us to monitor those streams, and we often rely on some of those smaller groups or First Nations or NGOs or community organizations to monitor some of those smaller systems. And so I suppose that with the Pacific Salmon Strategy Initiative, there could be some more capacity for monitoring some of those systems that you've mentioned. But I don't know exactly which systems we're not monitoring and if they're back on our radar now.
Thank you so much for that question. And Lauren, you also flagged a question in the chat, so please go ahead and we'll turn to you. Ahead.
Hi, Erin. Thanks for your talk. That was really interesting. I was just wondering, at one point you mentioned hatchery fish, and how do hatchery fish contribute to the population that you're monitoring, and are those included as wild fish in the when you talk about wild fish?
So no, I think that in the example that I had mentioned, mark selective fishery, I think maybe is what you're referring to. So the way that a mark selective fishery would work is that the hatchery fish are for a particular population, their adipose fin is removed, and then upon return to the rivers, those hatchery fish would be selectively removed, because you can identify a hatchery fish by its lacking of an adipose fin. So they're selectively removed from the system for harvest and for broodstock as well. And so the idea would be to reduce the impact on the wild populations by just selecting only those populations that are missing an adipose fin or originating from a hatchery.
Thank you, Erin. I really regret that I can't hear further in detail. My question is about like the drone footage. If I'm not mistaken, you said something about like recognizing the depths of fish school, but I can understand how can you realize that with drones.
Actually, what I had said was, and I was probably speaking quickly because I do. What I was saying was that the drone footage allows you to get the kind of the surface of the school, whereas the snorkelers, so the snorkel survey or the escapement surveys, so the folks that are in the water, they're able to look at the depth of that school and the density of that school. So it's a combination of those two, of being able to use a drone to look at maybe the extent and also to spot some of those schools of fish, and then also getting in there with our own eyes to be able to see how concentrated that school actually is, to better estimate the number of fish in that particular group or school.
Hi, Erin. Good to see you. And thanks for the nice overview. So you mentioned the changing environment there at the end. And I was wondering if stock assessment is actually doing any work to understand how environment is really impacting fish, or working with departments who do. So like, in other words, how are you taking into account the impacts of changing environments on Chinook salmon in your process?
Yeah, so we are, one thing that I didn't really get into was some of the ecological monitoring that we've been doing. I mentioned the hydromet stations, but we also have been doing some lake surveys and also ecological monitoring of some of the rivers. And I think that now we are, we've got a bit of a, not a time series, because it's kind of a new, for the hydromets, we've got a little bit of a time series, but for the for some of the other benthic invertebrate surveys and some of the other surveys that we've begun, I think that's a newer program. So the idea is, yes, to be able to correlate the conditions, at least in freshwater, with freshwater, I guess, productivity and survival. And that's one of the projects that's underway right now, Brian.
I'd like to know more about the hatchery fish, and how many hatchery fish or what proportions are ending up in spawning rivers. I assume you separate them out when you do the counts. And if you do, are you also determining the source of origin of those hatchery fish? Like, which hatcheries have they come from?
Hi, Andrew. Yeah, thanks for the question. Yeah, so we have one of our biologists who has been dedicated to just that and looking at straying of hatchery fish on into other systems. So that is one of the projects where we have been putting some effort, is looking at the natural versus the hatchery inputs into the systems, and then also the straying component. And if you'd like more information, some specific information on that, then just email me.
Okay, and right now are those numbers in some of the reports you referred to, or they're not being reported yet?
No, they wouldn't be in the bulletins that we produce, because that's kind of that's more of an analysis of many different populations and systems, and very specific. But we do have a report that's being developed. It's in the final stages, so we could potentially send you a draft. That's something that that Wilf Lukey has been working on for the past while, and he's working with one of our biologists, Jacob Wheel, on developing that paper. And I think they're about ready to submit it for review to maybe the CSAS, but I'm not certain.
Thanks so much. I'll get in touch.
Okay, sounds good. Thanks, Andrew. Yeah, and thank you everybody for attending. This was really great. It really forced me to learn more about the awesome work that stock assessment does.